Okay, so today's lesson, we're going to be putting it all together is the title of the lesson. We're going to take things that we already know how to do, and we're going to put them all together. So you already know how to factor a monomial from a polynomial. If we had something like 9x squared plus 3x, we could factor out the greatest common factor. Remember doing this?
Nope. Negative.
Carly, what would a greatest common factor be of these two terms? Well, we need one factor that they both have in common. 3. And then what variable? We also have a variable factor. 3x. So we could take out a 3x. What would we be left with inside? 3x. 1. Good. So 3x plus 1. So we did that way at the beginning when we first started factoring. Up here, Cameron. We did this right when we first started factoring. Then we moved on to factoring trinomials where a equals 1. That's the kind where we use the tic-tac. Then yesterday we did how to factor. A couple days ago we did the difference of squares, and we did perfect square trinomials. So in this lesson we're going to do what Stephanie figured out. We're going to factor a monomial out first. It may just be a constant, it may just be a variable, it may be both. We're going to factor that out, write what's left, and then we're going to have to factor what's left because we might end up with a trinomial or a difference of squares binomial or a perfect square trinomial. Okay, so let's take a look at the examples. First example, we have 2x squared plus 2x minus 4. Anthony, if it's hard for you to see there, you might want to move somewhere where you can, but it's up to you. Just make sure you can see well enough to write everything down. Okay, so I could factor something out of here before I start. Just looking at this, I can't use the tic-tac, at least not the way we've learned to do it. When you get to Algebra 2, you'll learn more about that. Can't use the tic-tac because this is not 1. This is a 2. And this is not a perfect square because you can't take the square root of 2. So you know what? You have to do something else to it. So we're going to factor out a monomial. Carly? By 2. Yeah, you could divide them all by 2. So we'll factor out a 2. What are we going to be left with? Minus 2. Good. Now we need to factor the trinomial that we got. So this is where we can use the tic-tac. We do -2 and 1. What two numbers multiply to give us -2 and add to give us +1? 2 and -1. Can't be too hard because we only have one pair of factors for 2. So 2 and -1. So we end up with 2 is still a factor, x plus 2, and x minus 1. So we have 3 factors that make up that number. It's kind of like saying 3 times 2 times 2 would be, let's see, 6 times 2 would be 12. If we express 12 as the product of prime factors, it would be 3 times 2 times 2. This one is 2. This is the second factor. It's x plus 2. The next factor is x minus 1. So -1 by itself is not a factor of the whole thing. It's this whole term in parentheses. Factors are the things that we multiply to get the original. Okay, next one. Rebecca, what's the greatest common factor of those 3 terms? It would be 3. Okay, what's going to be left? Good. Now, let's try to factor this without writing down the tic-tac. We're just going to think the tic-tac in our head. So we're going to have x plus or minus something and x plus or minus something. So think about what 2 numbers multiply to give you 28, add to give you 11. Anybody want to tell me what those are? Emily? 7 and 4. So we have x plus 7 and x plus 4. So our 3 factors are 3, x plus 7, and x plus 4. When you guys were doing King's painting, you kind of lacked the open-ended King's painting. You were kind of uncertain about what exactly it meant when you were taking a factor of this. We're going to talk about that on Monday. Okay, Anthony, greatest common factor of the next one?
1.
Well, 1 is the greatest coefficient common factor. What about variables? Do you have any variables in common?
X.
You have x, good. So if we take out x, what do we have left?
X to the second.
Uh-huh.
And X in the second.
At just x, uh-huh.
And minus 30.
Minus 30. Good. Now, when we go to the next step, make sure you keep bringing down this x because it's a factor. So I'm going to bring down my x. And I'm going to just set up the framework. Tell me two numbers that multiply to give you negative 30 and add to give you 1.
30 and 1. Wait, no. What?
Two numbers that multiply to give you negative 30.
5 and 6.
5 and 6. Which one's going to be negative?
What do I have to get? Negative 1 or
You have to
positive
get
1? 5 is going to be negative.
Right. So we have x minus 5 and x plus 6. Okay, the next three are examples for you to try. So if you're watching this at home, pause the video, try these on your own, and then come back for the solutions. Okay, first one. Claudia, what did you end up with?
I got, say the answer.
Mm-hmm.
4 parentheses x plus 10, then x minus 1.
Okay, I almost agree with that. Emily?
Negative 10.
It should be negative 10, because when we factor out a 4 here, we end up with x squared minus 9x minus 10. We want this 9 to be negative, and yours would end up being positive. So let's just switch those two signs around. So it's x minus 10, x plus 1. How many of you got that one right? Okay. Good, next one, Hope. Did you finish it?
Yeah.
Okay, tell me what you got.
5 parentheses x plus 2, and then x plus 1.
Good. I do agree with you on that one. Okay, Noah. What's my greatest common factor for this one? X squared. So they all have x's. The smallest number of x's in any of the terms is x squared. So we take out an x squared. What do we have left? Noah? Oh, what?
No.
More than x. X to the fourth divided by x squared. Yeah, x squared.
Plus 3x
Good.
plus 2.
Good. Nice. Okay, now we need to factor the next step. Someone else do the next step for me. Any volunteers?
No, I don't have this number.
Go ahead, Reagan.
Then it's x squared,
Mm-hmm.
parentheses, x plus 2, and then x plus 1.
Good. So it actually has two of the same factors as the previous problem. It just has a different third factor.
That's strange.
Okay, any questions? Okay, let's look at some more examples. These ones are examples with difference of squares. So if you look at the first one, 2x squared minus 32. This does not appear to be a difference of squares problem because you have a 2 here. You can't take the square root of 2 and get an integer. And you have 32, and you can't take the square root of 32 and get an integer. So it doesn't appear to be difference of squares, but then if you think, well, could I factor out a common factor, it's going to turn into difference of squares. Stephanie, what is my greatest common factor of those two numbers? 2. So if I factor out a 2, what am I left with? What do I have left?
Oh.
Mm-hmm. 32 divided by 2? 16. Okay, and then factoring this difference of squares, what do we get? Keep going, Stephanie.
Um, 2 x squared minus 32. 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 2 x squared minus 32.
square root of x squared? X and the square root of 16?
Or
4. So difference of squares, we have
X
x minus 4, and what's the other factor? Now, if we square it, we're going to have a middle term. What do we have to do so that we don't have a middle term? This is a binomial, not a trinomial. If I just square this and I multiply it, what's that? X plus 4. Good, yeah, we need the opposite sign. Otherwise, if I just square one of these terms, or one of these factors, I'll end up with a trinomial, not a binomial. The only way to end up with a binomial when I multiply two binomials is to have something cancel out. Okay, Reagan, what should I do first on the next one?
X, what would this be? X squared, or X squared.
What's the biggest thing I can factor out?
X.
X. I can factor out X. What am I left with?
X squared
Uh-huh.
minus 4.
Good. Okay, let's factor that further. I'm going to bring down my X. What does X squared minus 4 factor into?
X minus 4 plus, wait, X minus 2.
There you go.
Plus 2.
Good. X minus 2. X plus 2. Difference of squares always have different signs. Okay, next one. Anthony.
Great.
What can I do first up there?
Divide by 5.
Okay, 5 is part of the greatest common factor, but it's not all of it.
5x.
Keep going. More than that.
Squared.
5x squared. Good. If I take out 5x squared, what am I left with?
X squared minus 25.
It is 25. Okay, now, if I further factor this, I'm going to bring down my 5x squared as a factor. What does this difference of squares factor into?
Wait, I used the thing.
No. Look at the other examples of difference of squares.
Oh, it's 5.
Yeah, so what are my two factors?
X minus 5. Parentheses x plus 5.
Good. Okay, there's 3 on here for you guys to try. I'm going to pause this. Okay. Oh, it's recording. Okay, 5x squared minus 45. Emily, tell me what you ended up with.
You divide by 5.
Okay, so what would my second step look like?
Okay. 5 parentheses x squared minus 9 parentheses.
Okay,
Okay, then 5 parentheses x plus 9 parentheses x minus 9 parentheses.
okay, wait a second. So you took the square root of
Wait,
x
it's
squared.
3.
3, there you go.
I read it wrong, then I wrote wrong. Same thing. Hey, I was just thinking ahead of myself.
Okay, Haley, next one. What can I factor out?
X to the
X to the
third.
third. So my second step is x to the third parentheses what?
X squared minus 64.
Okay, what's my last step look like?
X to the third, parentheses, X minus 8, and X parentheses, X.
Nice. Okay, last one. A few of you had some trouble with. Cameron, did you
True.
do the last one?
Yeah?
Okay, what is the greatest common factor?
Hmm?
What's the greatest common factor?
6x.
6x. What am I left with?
6x squared minus 1.
Wait a second. If I have 6x, if I divide this by 6x, the
X
6,
squared.
yeah, just x squared minus 1. This is where a lot of people got a little bit confused. 6x divided by 6x is 1, not 0. Okay. Now, Cameron, what would the next step look like?
X minus 1.
Wait a second, we need to use this factor also.
Oh, 6.
Yeah, 6x.
Yeah.
We still have our 6x. Okay, now.
X minus 1. X plus 4.
Good. questions about this?
Negative factor.
Okay, last section. We don't have a lot of time, so we may do all of these together. Examples with perfect square trinomials. Some of these are going to be perfect square trinomials and some aren't. You have to factor out a monomial before you can tell whether they're a perfect square trinomial or not. So this one, when we look at it, does not appear to be a perfect square trinomial. You can't take the square root of 2 and get an integer. You can't take the square root of 72 and get an integer. So it doesn't look like it is, but what could we factor out to make it simpler? Cameron?
2.
A 2. What will we have left?
X, 2, x squared
Uh-huh.
plus 12.
Uh-huh. Good. Okay, now is what we're left with inside here, is that a perfect square trinomial? We could use the tic-tac to factor it also, because we don't have anything in front of the x. But is it a perfect square trinomial?
Yeah.
Okay, Hope, how do you know?
It just works like that.
I know.
Okay, Anthony?
So square root of x to the second, right? That's x. Square root of 36, that's 6. 6 plus 6, 12. Boom, perfect square.
There you go. Excellent. He explained that very concisely. You need to be able to take the square root of the first and last terms, multiply them, double it, and get the middle term. So Anthony, what would my factor be that I'm going to square?
What did I say the outcome was?
Well, you explained how you would get this. So you explained that this was the square root of this was x, square root of this was 6, but how do I put that into a factor?
7x minus 6
No, we're not going to
Plus
need
six.
x plus 6.
squared.
Squared, good. We just square each square root. Okay, Carly. Next one also does not appear to be a perfect square trinomial. What could you factor out of it? We'll look at it a little closer. What could we factor out of this one? 3. Okay, what will we be left with? Plus just 7? 7x plus 9. Good. Now, is this a perfect square trinomial? No? Why not? Yeah?
Square root of x is, x to the second is x. Square root of 9 is 3. 3 times the x times 2 is not 7, or whatever number that is.
Yeah, it is a 7. Excellent. Yeah, that was very well explained. Good, that was even better than last time because you explained the multiplying. Good. Good, so it's not a perfect square. Could we use the tic-tac? Let's see if that'll work. If we put a 9 up here and a 7 here, are there 2 factors of 9 that add up to 7?
7 and 2.
7 and 2 are not factors of 9. Factors of 9 are 1 and 9 and 3 and 3, and neither works there. So this is as far as you can go with this. All you can do is factor out the 3. That's it. Okay, next one. Rebecca, what should I do first? Take out 5x. Good. What am I going to be left with? I'm making all good little mistakes. 5x. Okay. What will I be left with? Good. Is this a perfect square trinomial?
Wait, yeah.
Yeah, it is. Okay, so what would my other factor be?
The x plus negative.
Or just x
No,
minus
yeah,
2?
x
Uh-huh.
minus 2.
To the second. Excellent. Good. Okay, we only have 4 minutes left, so we're just going to do the last 3 together. Your assignment is going to be just to work on the mixed examples at the bottom of this page. We didn't get deep enough into this for me to feel comfortable giving you a whole assignment. Okay, Claudia, do the next one for us.
Which one?
This one.
You're gonna divide everything by 3.
Okay?
So it's 3 parentheses x to the second power minus 6x plus 9.
Okay, is that a perfect square trinomial? Okay, what's your other factor?
Oh, what?
Can you factor the perfect square trinomial?
Yeah. X plus 3 to the second power.
Not x plus 3, because this middle term is negative.
Negative 3
Uh-huh.
parentheses to the second power.
Good, very good. Don't forget, if the middle term is negative, you have to use the negative square root, not positive square root. Okay, middle one. Hope.
Great, Laura.
That's okay, you didn't have to do this one on your own. Greatest common factor. We're just gonna go.
2x to the third.
Excellent. 2x to the third. What are you left with?
X to the second.
Good.
Plus. Half of 36.
What is half of 36?
Don't know. 18
18. X.
to the said 1.
Yeah, it's just to the 1.
And then plus, no, should we do like 10 minutes?
10 minutes. Oh, you didn't pull it.
No, it's not 18. 18 was the middle. What's the last one? 81. Okay, is that a perfect square trinomial?
Negative.
Okay, what would the middle term have to be for it to be a negative, or for it to be a perfect square trinomial? Okay, what's the square root of x squared?
X.
What's the square root of 81?
9.
9. 9 times x is just 9x, and if you double that, you get,
It is 1.
it is 1. Okay, so what's my other factor?
9. Oh,
Just a 9 here, or?
Oh, it's X plus 9.
Good.
To the second.
To the second. Good, nice. All right, one more. Let's see who's the lucky person. No.
No way.
What can I factor out?
Gee.
X.
Okay.
X to the second plus x plus 1.
Okay, is this a perfect square trinomial?
Oh,
No, I don't know. Okay.
Yes.
What's the square root of x squared? What's the square root of 1? Okay, 1 times x is 1x, and if you double that, what do you get? 2x, and this is not 2x. So it's not a perfect square trinomial. And there's actually no other factors, because there's no numbers that multiply to give you 1. That would all be hard. Okay, so just the last slide is your homework.